Start with our first case study. This is the SQL query which I have executed. Okay. Select employee ID first name from employees where e dot phone number is equal to this. Okay. And hire date is greater than 30th Jan 2004. And e dot commission percentage is 0.25 and 0.15. And e dot employee ID is between 100 and 175. Okay. And this is the output I am getting. Only one row is getting selected when I run this query. This is the plan which the Oracle has taken to execute the query. This is the plan, and these are the access and predicate information. So when I see the output of the query, I am expecting only one rows. So when I see the execution plan which the Oracle has taken, so I have to make sure whether this plan is good or not. Looking at this execution plan, do you see expected rows 77, right? I am expecting only one row out of the select query. However, Oracle is using such an index and it is scanning 77 rows. Okay, so this tells me that Oracle is not actually executing a query in a faster way. So this is an employees table. It has got only 107 rows out. Okay, so in this case, it may run fast. So in this case study, I am expecting only one row, but after scanning, Oracle is expecting 77 rows out of this index. Okay, and so before we start with this, if you go with a parent-child relationship, second operation will execute first. Okay. So what is the second operation? Second operation is nothing but accessing the employees table using employee ID is greater than 100 and employee ID is greater than 175. Correct. So it is scanning, accessing the employees table, this employees table using this part of the clause. Right. So it is accessing your employees table using this part of the where clause. So I still have three more other clauses present in the where part, but Oracle is accessing this part. So it is scanning between 100 to 175. That means it has to scan 75 rows or 76, 77 rows first. Okay. So that's why it is showing as access method here as employed between greater than 100 to 175. Okay. And whatever it has been scanned, whatever 75, 76 rows it has scanned, then it will go for a filter. Okay. So what is that filter? That is nothing but your operation one. So it will, from that 76 rows whichever is qualified, it will try to apply the filter, and filter will be whichever rows is not having phone number is equal to this, whichever row is not having higher date greater than this, and commission percentage in not in this, all rows will be discarded. Okay. So out of 77 rows, all 76 rows will be discarded and output will be 1. So it will first access your employees table using this part of the clause. Okay. And that's why it is expecting 77 rows. And from this access part, it will then try to filter out the unwanted rows. So the unwanted rows are these three columns. Okay. So it is first scanning 77 rows, and out of that it is discarding rest 76 rows and giving back my one row, and that is the reason why I'm getting one row as the output. Okay. So this term appears to be a little lengthy operation, correct? And it is going to take time. So can we do anything better or to tune this query? So let's go back to our fundamental approach for a single table. So fundamental approach for a single table states that you starts with such a column which is going to give you less number of rows. Okay. So I have 4 columns in the where part. So we already discussed this. So employee ID, if I use this employee ID, it is going to give me around like 76 rows, correct? So this will be little lengthy operation. If I start with commission underscore percentage in this, so commission underscore percentage is having only 7 distinct values. Okay. And employees is having 107 rows. So before we start that, let's see the view underscore stats information for the employees table. Okay. So this is the statistics for employees table. It is having 107 rows. Okay. And if you see the employee ID column, okay, it is having 107 distinct values, and it is having 107 rows as well. So this is a very good candidate. Employee ID is a very good candidate to start with. But the problem what happened is it is saying employee ID between 100 and 175. So even though employee ID is unique, even if I still start with employee ID, it is going to give me 76 rows. Okay. So that is the reason why in this case your employee ID is not going to be a good candidate or a good where clause column to start with. So next was our commission underscore percentage column. So if you see commission underscore percentage column is having only 7 distinct values and number of rows are 107. So commission underscore percentage is such a column which we cannot use because number of distinct values are very less. So if I divide 107 by 7, I will be expecting close to one value will repeat 20 number of times. Okay, if you have a histogram distribution, then definitely it will tell you how many times each value has occurred. But if I go just blindly with a simple calculation, it will say that one value will repeat 20 times. Okay, so that's why commission underscore percentage again may not be a good candidate, correct, to start with based on the fundamental approach. Okay, so what is the next column? I have hire date. So hire date is greater than 30th Jan 2004. So if I say hire date is greater than 2004, then it is possible that it will qualify for all the rows in the table, right? So first row may start with 2004 and it will have entries till 2019. That means if I access the employees table using this hire date, it will qualify for all the rows. So again, this may not be a good candidate to start with. Okay, so if you see the histogram distribution hire date, it is having 98 distinct values, which is a good thing, but it is not an equal to operator. It is greater than operator. So greater than operator means it can scan all the rows which is greater than 2004. So if you see the distribution, low value is 2001 and high value is 2008, right? So this query, hire date is greater than 2004, will qualify for all rows between 2004 to 2008. So again, this is going to give me lot number of rows. So hire date again is not a good candidate, right? The only column left now is phone number. Okay, so let's see the histogram distribution, sorry, stats distribution for phone number. So if you see a phone number column, so it is having 107 distinct values, correct? And it is having 107 rows, which means this is a column which has got equal as many distinct values as the number of rows. So this is a very good column to start with. And it is showing equal to operator. So that means I have 107 rows in the table. I have 107 distinct values for employee phone number. So if I start with this column, and since this is an equal to operator, this is going to give me only one row, right? So if I access the employees table using this column, it is going to qualify for only one row. So this satisfies our fundamental approach for a single table, which states that you start with such a column in the where part of the clause, which is going to qualify for less number of rows, or which will expect least number of rows. So out of all these four column condition, this is the only column which will satisfy the for less number of rows, that is nothing but one row. Okay, so why Oracle has not taken access the table, sorry, access the employees table based on phone number? That is because we don't have an index created. Okay, this is the index tags for employees table. So we don't have an index created for the phone number column, right? So that is the reason why Oracle has not taken the access the employees table via phone number. So if you forcefully pass a hint to start with your phone number as the column, okay, so it will go for a full table scan instead of your index scan, because we don't have a index on the phone number. So the resolution to execute this query in a faster way is to create a custom index on the is to create a simple index on your phone number column. Okay, so when you create an index, so this is the description I have mentioned, you can read this. So whatever I discussed, I just mentioned it here. So if I create an index, custom index on your phone number, okay, and then if I execute a query, it is qualifying for only one row, right? Why? Because it is accessing your employees table using the phone number column, right? And when you access the employee using phone number column, it is accessing only one row, and from that one row it will do a table access by index row ID. That means nothing but your filter operation. So in that one row, it will try to filter out wherever your commission percentage or employee ID is not having this satisfying condition. Okay, and it is giving me one row back. So in this case, creating a custom index has helped to creating a simple index has helped to execute the query faster. Okay, so if you still want to validate whether my other columns are not good, you can always run this query. This is equal to the histogram distribution for a column. So when you run select count of star from employees where phone number is equal to this, you're getting one row. When you're running select count of star from employees where hire date is greater than this, you're expecting 91 rows. Okay, so this is not again a good. So if you run select count of star from employees where commission percentage in is this, you are expecting 11 rows. And similarly for this clause. So you can also create a composite index. So if you run a query where employee is between this and hire date is between this, you're still getting, and commission percentage in this, you're still getting 10 rows. So out of all these conditions, you're seeing that if I create an index on phone number, I'm always expecting one row. Okay. So in this case, this phone number column is the best candidate to start with. Okay, and that's why we should create a custom index or a simple index on the phone number column. So in this way, it will help to execute the query faster, and you're expecting one row. And yeah, so that's how this solves the query purpose. Let's start with case study number 2. Okay, so this is again a case study with two tables. The earlier one which we saw was for one table. Now this is for two tables. So this is the query. Select first name, last name from employees, comma departments, where employee ID is equal to 101, right? And hire date is greater than 2004, and hire date is less than 2006. So between 2 years of data, they are expecting as the hire date. Then they are joining the E dot department ID is equal to D dot department ID, and we have D dot location ID is equal to 1700. Okay, so this is the select query, and when I run the select query, I am expecting only one row as the output. Okay, so this is the execution plan Oracle has taken, and this is the access and filter predicate. Okay, so let's start this with a fundamental approach for query tuning for the two tables. Okay, so what does the fundamental approach says that if you have a query with two or more than two tables, you don't start with a join operation. You start again with a where part of the clause, which is going to give you less number of rows. Okay, so in this case, we obviously will discard accessing or starting my query to execute using this join operation. Okay, so obviously this part of the where clause is gone. I mean, with this part of the where clause we won't be starting with, so you can discard this as an initial approach. Okay, so out of if I discard this, so I have four more where clause part left. Okay, these three, and location underscore id is equal to 1700. Okay, so let's see if I access my employees table using the employee id, how it will give me. So if I access my employees using the employee ID is equal to 101, it is going to give me only one row, correct? So this obviously becomes the very good candidate to start with, because when I start accessing my employees table using the employee ID, and since employee ID is already having an index, it is going to give me only one row. Okay, so this is a very good candidate to start with. Okay, so let's see other candidate, hire date. So if I start accessing the employees using a hire date, it is going to qualify from 2004 to 2006 data. So it is possible that this will give me 50 rows or 100 rows. Okay, so this obviously is not a good candidate, because again it is having a greater than and less than operator. Okay, similarly I have d dot location id is equal to 1700. Okay, so this again can be a good candidate to start with. Okay, so we will further see whether this is a good candidate or not. Okay, so looking at the execution plan, so this was the approach we wanted. So where e dot employed is equal to 100, which should execute first, correct, because it is expecting only one row. This one row should go for the join operation with the d dot department id. Okay, so since in this join operation, departments is built on department id. Okay, so and department id is a primary key in the departments table, so this join operation is again going to give me only one row. Okay, so this is the approach which we want Oracle to follow, correct? So let's see whether Oracle has actually adopted this methodology. So if you see the execution plan, right, and if you make it as a parent child relationship, then third will execute first, then two will execute, five will execute first, third, and then fourth will execute. Okay, so in this operation third will execute first. So let's see third, what is the third operation doing, right? So third is accessing my employees table. Okay, first accessing the employees table using the employee id. Okay, and it is expecting only one row. So Oracle has actually did what we wanted to do, right? What we wanted to do. So it is accessing the employees table first using the employee is equal to 101. Okay, so first three will execute, then two will execute. Two is nothing but your table access by index row id, and since in employees table multiple columns are present, so filter will come into picture. So it will filter your employees table based on your hire date. Okay, so whichever if employee id 1 is not falling between 2004 and 2006, that will be discarded, but in this case it is falling, so that's why it will be applicable. So Oracle has scanned e dot department e dot employee id is equal to 101, then it did a filter operation. Okay, after that, what is the next operation? Next operation is fifth. So fifth is nothing but your access using the join method. So whatever row employee from the employee is equal to 101 he it has got, it has going for the join operation. And this join operation is again going to give me only one row, because in departments table department ID is the primary key, and then the nested loop join happens between them. Okay. And since in the D column in the departments table I have a location ID is equal to 1700, that will come as a filter for the fourth part. Okay. So after the join operation, whatever, if that join row is not having location ID is equal to 1700, that will be discarded. But in this case, location ID was 1700, that's why it got qualified. Okay. So what we wanted Oracle to execute and how the Oracle has actually executed this query is same. Okay. So we can say that this query is already going with the best plan. So we don't need such kind of troubleshooting in this case. Why? Because you see everywhere the expected row is 1. So blindfoldedly you can say this query is already executing with the best plan. Okay. So that's the reason why no more tuning can be done in this case. Okay. Because it is already executing with the best plan. So this is the stats distribution for employees and departments table. Okay. So one more thing was like you can verify using this query also. Select count of star from employees, where employee is equal to 101. It has given me one row. And there was one more where clause, right? Location underscore ID. See, why is it not good to start with location ID? We'll see that. So if you see the stats distribution for location ID, it is having only 7 distinct values, and total number of rows are 7. So each value may occur 3 times. So if I start with location ID is equal to 1700, it is possible that there will be 3 rows with 1700 as the value. But I already have an employee ID which I am expecting only one row always. Okay, so that's why employee ID will be a better column to start with rather than the location ID. You have to still verify that. You can always run this query, select star from departments where location ID is equal to 1700. So this is expecting 21 rows. Okay, so that is the reason why starting with employee ID will be the best approach to tune this query, and Oracle has actually done that. So in this case it is already going with the best plan and no more further tuning can be